I hope you're doing well. I miss seeing you guys so much. And I wanted to give you your notes for dividing monomial radical expressions. So if you'll remember, when we talked about polynomials, we discussed the difference between a monomial, a binomial, and then polynomials. So a monomial is simply one term. Binomials would be two, and so on. So for this video, we'll be talking about monomial radical expressions, and in the next video, I'll be talking about dividing binomial radical expressions. So it's important that we get a good grasp on this first before we move on to the binomials. Alright, so let's look at this first question. Does the square root of 3 over the square root of 5 mean the same as square root of 3 over 5? Yes, it does. And the reason for that is that we can have, let's say we had the square root of 16 over the square root of 4. So that would be 4 over 2, right? Well, we could also say square root of 16 over 4 is, if we took the square root of 16, we'd get 4. Square root of 4 is 2, so they're the same thing, right? So that's perfectly fine. So usually when we see it in this form, we're going to want to rewrite it using two radicals here. Alright, but here's the deal with dividing radical expressions. We can't leave the radical in the denominator. We have to rationalize it. Now, if you'll remember, we've been working a lot with rational expressions. So what does it mean to rationalize the denominator? Well, I'll show you. So if we had, for example, number 1 here, the square root of 3 over the square root of 7. We want to get that square root out of the denominator. So we need to figure out how we can manipulate this without changing the value, really. So here's what we're going to do. We're going to multiply by square root of 7 over the square root of 7. Because what is this technically equal to here? If we have any number over a number, let's say we have number over a number, that's just going to give me 1, right? So square root of 7 over square root of 7 is simply 1. So we're just multiplying by 1. We're not changing its whole value. We're just kind of manipulating it so our radical is not going to be on the bottom anymore. Alright, so if we multiply this straight across, we're going to have square root of 7 times square root of 7. That's just going to give me 7. Because if I have the square root of 7 squared, that square root is going to cancel with the squared, and I'm going to be left with 7. Alright, so then on top of that I have square root of 3 times square root of 7. It's going to give me square root of 21. Now I just need to check. Can I simplify it anymore? Are there any factors that I can take out of 21 where one of them's a perfect square? And I can't. So that's going to be my final answer. The square root of 21 over 7. So we can have a number in the denominator, but we cannot have a radical in our denominator. So to rationalize the denominator, we're going to multiply it by 1. And all that is, we're going to take whatever the denominator is and multiply it by itself, over itself. Alright, let's look at this second example here. So this is square root of 5. Here, I'll rewrite it here. That may look a little messy. Square root of 5 over square root of 2. Alright, so we're going to be multiplying here by 1, right? Because we don't want to change the value of this expression. We just want to kind of manipulate it where our radical's not in the bottom anymore. So what am I going to multiply by? Square root of 2 to get rid of the square root of 2 on the bottom, and square root of 2 on the top. Alright, so if I multiply it across, I'd get square root of 2 times square root of 2 is square root of 4, and that's just equal to 2, right? So I'm going to have 2 on my denominator, and then the square root of 5 times square root of 2 is going to give me square root of 10. So once again, I check to see, can I simplify square root of 10 anymore? And from past examples, I know that 10 does not have any factors where one of them is a perfect square. So this will be fine for my answer. All right, let's look at number 3 here. we have the square root of 12 over the square root of 5. All right, so we have to rationalize the denominator. Now, if you'll think back to when we were doing rational expressions, remember how we had to find the least common denominator and then multiply by that to get rid of the denominator? That's essentially what we're doing here, but we're not actually getting rid of the denominator. We just want to get rid of the the radical in the denominator. So remember, we're multiplying by 1 technically, so the denominator is square root of 5, so square root of 5 over square root of 5, that's equal to 1, right? Because anything divided by itself is going to give you 1. All right, so square root of 5 times square root of 5 is square root of 25. And what is the square root of 25? It's just equal to 5. So my denominator is going to equal 5. Now you can kind of see a pattern here. Whenever I multiply a square root times a square root, it's just going to give me the number inside the radical if they're the same. All right, so I have square root of 12 times square root of 5, and I get square root of 60. All right, now I'm thinking, can I break down 60 into anything where it has a factor that is a perfect square? I'm sure I can, so let's just take a look. So what are some factors of 60? I have 1 times 60, 2 times 30, 3 times 20. Do I have any that are a perfect square yet? No. I have 4 times 15. Well, I know that 4 is a perfect square, so why don't I try that one? So square root of 4 times 15 over 5. That's how I like to go about it, just so I can see all my factors and see which one's gonna, where I won't have to simplify as much. You could choose 3 square root of 20, but you would have to simplify that down further. I just like to keep going till I have one specific perfect square. But however you choose to simplify those, that's fine. As long as you get it simplified all the way to its simplest form. So remember, we pull out the square root of 4 here. So what is the square root of 4? It's 2. So I'm going to pull that out of the radical. I'm going to have 2, and then whatever's left over, square root of 15 over 5. All right. Now remember, if we treat these like variables, we can't simplify this any further because this is technically 2 square root of 15 over 5. So the only things we would look to simplify is our fraction here, so the numbers, and if we had another radical on the bottom, we could simplify those. But we don't because we got rid of that radical. All right, so we're looking to simplify as far as we can. All right, let's look at this question here. Are square root of 15 over 6 and 15 over the square root of 6 the same? I don't know. Actually, well, I do know, but let's check it out first and see what we find. So remember I said at the beginning, if we have one written with a big radical, we can go ahead and break that down. So square root of 15 over square root of 6. Then I can rationalize the denominator. So remember, I'm going to multiply by whatever the denominator is over itself, because that's just equal to 1, right? All right, so square root of 6 times square root of 6 is just going to give me 6. And if you're still confused why, square root of 6 times square root of 6 is square root of 36. And then what is the square root of 36? It's going to give me 6. So that's where that came from. All right, and then the square root of 15 times square root of 6. If you need to use a calculator, that's fine. If you can do it in your head real quick. But that is just a square root of 90. All right, so now we have to simplify as far as we can. Can we simplify this radical here? So in other words, are there any factors of 90 where one of them is a perfect square? And I know a really simple one already, so I have square root of 9 times 10 over 6. All right, so now I'm going to take the square root of 9 here and pull it outside. So what is the square root of 9? 3. So I'm going to pull that outside, and then I'm left with 10 on the inside over 6. All right, I can't simplify this radical any further because I don't have any factors of 10 that are a perfect square, right? I have 1 times 2 and 2 times 5, none of which are perfect squares. So that's fine. Now, what I can simplify is this fraction here. I have 3 over 6. So what does that simplify to? If I reduced this fraction here, 3 over 6 is just 1 over 2. And don't forget your square root of 10 there. So you could write it as this, or if you wanted to simplify, you could just write it as square root of 10 over 2. Alright, so let's try this one here. So remember, I'm rationalizing the denominator here. So I multiply by the denominator over itself, or multiply by 1. So this is going to give me 6 like I saw before. 15 times the square root of 6 is just 15 square root of 6. Alright, now I'm looking at my coefficients here. Can I simplify my coefficients? Or in other words, can I reduce that fraction? So 15 over 6, what do they both have in common? They both have a 3 in common. So if I pulled a 3 out of this, that's going to give me 5. If I pull a 3 out of that, it's going to give me 2. Or in other words, if I divided by 3 on both of those to reduce, I would have 5 halves square root of 6. So 5 square root of 6 over 2. And are these two the same here? They're not the same. So that is a answer to our question. These two are not the same because if you'll look at our example from earlier, the numerator and denominator both became radicals because they were both under the radical. So in this case, they're not the same. Alright, so here are 3 things we're looking for, 3 basic things. So we don't want a radical in the denominator, so we have to rationalize it. Alright, next, when we get to our next step, we want to simplify the radical. So for example, here, we had square root of 90. So we simplified that to 3 square root of 10. So that's step number 2, simplify the square root. And then the third step is to reduce the fraction. So for example here, we had 15 over 6, which we could reduce. So then we reduced that and we got our final answer. So these are the 3 things you want to look for, and there are 3 steps. I'll make another short video with a few more examples just to give you a good grasp of the concept. But these are your basic notes for dividing monomial radical expressions. I hope this helps, and if you have any questions, please let me know.